Today we are going to talk about exponential and logarithmic equations. This is section 3.4 in your textbook. The essential question for this section is, what are the different techniques that can be used to solve exponential and logarithmic equations? We'll begin by talking about exponential equations. So what exactly is an exponential equation? An exponential equation is an equation containing a variable as an exponent. So let's look at an example. For example, say I've got 2 to the 3x minus 8 equals 16. Notice we have the variable x appearing as an exponent. So how would we go about to solve this? Well, first of all, if we look at this, we should ask ourselves, is 16 a power of 2? And if you think about it, it is. And then our example might look like this. So now we've got 2 to the 3x minus 8 is equal to 2 to the 4. Well, notice we have the base of this 2 in both cases. So since I've got 2 in both cases here, I can simply set the exponents equal to each other. So now we have 3x minus 8 equals 4. So if I add 8 to both sides of the equation and divide by 3, I get my solution. X, in this case, is simply equal to 4. So we have solved one type of exponential equation. So let's look at another example. Say I've got 4 to the x equals 15. Well, it's obvious that 15 is not a power of 4, so how are we going to approach this? So if I take the log of both sides, I end up with log 4 to the x equals log 15. Now notice, I use common logs here because I don't show the base. It's assumed to be 10. I could have just as easily used natural logs. It doesn't matter. In either case, you would get the same answer. So let's proceed to solve for x. So notice x is an exponent. So using the power rule, I can simplify the left side of the equation to be x times the log of 4 is equal to the log of 15. Now I can take it one step further and solve for x and get the result we're looking for. So x is equal to log 15 divided by log 4. If I look those up on my calculator, I get my final answer. X equals approximately 1.95. Another example of an exponential equation might look like this. 40e to the 0.6x minus 3 equals 237. Okay, so we're going to solve this by first adding 3 to both sides and then dividing by 40 to isolate the e to the 0.6x. So if we add 3 and divide by 40, this is the result we get. E to the 0.6x is equal to 6. Now, at this point, we can treat it like the previous example and take the log of both sides. Now, notice we've got e to a power. That e is not a variable, that's a constant, 2.718. So since I've got e to a power, I'm going to take the natural log of both sides rather than the common logs. I could do either, but I'm going to just go with the natural logs. I think it might be just a little bit easier. So now I have the natural log of e to the 0.6x is equal to the natural log of 6. Again, I'm going to use the power rule and move the 0.6x exponent out. So now we have 0.6x times the natural log of e is equal to the natural log of 6. Well, one of the reasons I picked the natural log of on this problem is because the natural log of e is actually log of e to the base e, which is simply 1. So this goes away, all right? Which leaves me with 0.6x equals the natural log of 6. If I divide both sides by 0.6 and figure out what ln6 is on my calculator and divide by 0.6, I'll get my final result. X is equal to approximately 2.99. So let's look at another example. Let's say we've got x in the exponent, but it's on both sides of the equal sign, all right? And our base numbers, 5 and 4 in this case, aren't powers of each other. So how do I approach this? Now again, I could have used natural logs or common logs. I just decided to use common logs. All right, so if we move the exponents using the power rule, our equation would now look like this. So now we have x minus 2, parentheses, times log 5. And on the other side, we've got 2x plus 3, in parentheses, times log 4. Now, if we remember that log 5 and log 4 are simply constant numbers, we can distribute, okay? So what I'm going to do right now first is distribute those to get rid of the parentheses. So now you have x log 5 minus 2 log 5 is equal to 2x log 4 plus 3 log 4. Now notice, we have two terms with x in them, right? So we've got this term right here has an x in it, and this term right here has an x in it. If we combine those on one side and move the other terms over to the right, we can factor out the x and solve for x. So our steps would look like this. So now we have x log 5 minus 2x log 4 is equal to 2 log 5 plus 3 log 4. Okay, if I factor out the x and divide both sides, I would end up with my final result. And if you crank the numbers out and stick them in your calculator, you should come out with approximately 6.34 for your answer. We have one more type of exponential function to deal with, and that is one that looks something like what we've got here, for example, 5. E to the 2x minus 4e to the x plus 3 equals 0. Now, if you look at that closely, that looks like it is somewhat similar to a quadratic, and we can easily make it a quadratic. Because if we let u equal e to the x, then our result would look like this. U squared minus 4u plus 3 equals 0. Now this is should be a pretty basic quadratic to factor. So if we factor it, our results would look like this. U minus 3 times u minus 1. And if we solve each of these for u could equal 3 or u could equal 1. But remember, we set u is equal to e to the x. So now if we plug e to the x back in for u, e to the x could equal 3 or e to the x could equal 1. Well, now if we solve these as two individual exponential equations, we can figure out what x is equal to. All right, so if I take the natural log of both sides on the left, I've got the ln of e to the x equals the ln of 3. Now if I further attempt to solve this for x, I will get x times the ln of e equals the ln of 3. Well, if you think about it, what is the ln of e equal to? The ln of e is simply equal to 1, so therefore this goes away, since that's just equal to 1, and my result is x equals the ln of 3. So that is one of my solutions. Now, let's look at the other side. The other side says e to the x equals 1. Well, what number do you raise, what power can any number be raised to and come out equaling 1? So on the right side, it's pretty obvious that the only value that x can have is x equals 0. So my two results for this particular exponential equation are that x could either equal the ln of 3 or x could equal 0. Okay, those are your two solutions. So now let's talk about logarithmic equations. Remember, a logarithmic equation is an equation containing a variable in a logarithmic expression, okay? And we're attempting to solve for that. So this falls into, I believe it's 3 different categories, so let's look at some examples. So the first example is, what if we have log base 2 of x minus 1 is equal to log base 2 of 4? Well, if you look at this, we've got a log of something equaling the log of something. And notice that both of these logs have the same base. So in reality, all I can do here is eliminate the term log and just have x minus 1 equals 4. Now be careful, you can only do this when the bases are the same. And notice, this is base 2, this is base 2. If these bases are not the same, you can't do this. But so long as the bases are the same, you can do this. Which gives us x minus 1 equals 4, solve for x, and x comes out equaling 5. So another example might look like this. Log base 10 of x plus 1 plus log base 10 of x minus 1 equals log base 10 of 8. Well, we got 2 logs on the left and 1 log on the right, so we can't just eliminate the logs. But if we combine the 2 logs on the left into a single log, using some of the properties of logarithms, we can go and use the same technique we used in example 1. So let's look at the left-hand side. When we get the sum of logs, remember that's the product rule. So now I have the product, the log of the product. Log base 10 of x plus 1 times x minus 1 is equal to log base 10 of 8. Well, now we're at the same point we were with the previous example, and I can eliminate log base 10 from both sides since the bases are the same and it's just a single log on both sides. So I can eliminate log base 10 from here, eliminate log base 10 from here, and just set the remainder of the problem equal to each other and solve for x. So if I multiply x plus 1 times x minus 1, I simply get x squared minus 1. The right side is 8. Now if I solve for x by first adding 1 to, subtracting 8 from both sides. If I subtract 8 from both sides, the result is x squared minus 9 equals 0. And now, if you look at this closely, this is the difference of squares, so I can factor this. And that gives me x plus 3 times x minus 3 is equal to 0. Now, if I set each of these factors equal to 0, so if I set the first factor equal to 0, I've got x plus 3 equals 0, subtract 3 from both sides, and I get x is equal to minus 3. Well, this would appear to be one of my solutions. However, if you go back to the original equation up here, we had log base 10 of x plus 1. Well, if x equals minus 3, you're going to have minus 3 plus 1, which is minus 2, and you're going to have the log of a negative number. There is no value for the log of a negative number. As a result, this answer is invalid. So x cannot equal minus 3. So we'll just ignore this and we'll move on to the next factor. So now I have x minus 3 equals 0. If I add 3 to both sides, I get x equals positive 3. Well, positive 3 is a valid answer. So our correct answer to example 2 is going to simply be x is equal to positive 3, and that is the one and only answer. So now let's look at our third and final example. Let's say I've got log base 2 of x plus 2 is equal to 5. Well, I've only got log on one side, so I can't cancel out logs, but what I could do is convert this into an exponential equation. So let's see what that would look like. So in exponential form, this would simply be 2 to the 5th is equal to x plus 2. Well, if I figure out what 2 to the 5th is and then solve for x, so now I have 32 is equal to x plus 2, subtract 2 from both sides, and I end up with x is equal to 30. And that will be my answer for this particular example. So x is equal to 30. There, I've got my solution.